let's speak about how to build beautiful visualizations. But before I introduce myself one more time, just without World of Warcraft part, let's try to think, why do we need to visualize our data? What benefits do we have from this? Because data could go with a really nice and simple view, like tables, right? Yeah, I know this is not aligned. I'm just really bad at CSS. Sorry. But like, who could resist tables? It's readable. It's nice. Okay, if you worked with Internet Explorer 6, you probably hate tables as much as I do, but in fact, human brain is designed in a way that takes patterns better than data in tables. And by patterns, I mean images. And sometimes visualizations could be really nice. This example is by Shirley Wu, and I was actually going to open the link on the right side, but unfortunately the internet is kind of flaky. So you can just search for film flowers. And here, this is not just a beautiful image. Every single flower has a different form which represents the rating, the different color that represents genre, and different size that represents a rating itself. So now we know why, and I can reintroduce myself. I am Vue.js core team member, and I'm actually at the right stage, because you can see, I don't know what Redux is doing next to Vue. It's so weird. But okay. And I'm actually jealous about this costume. I should have it and speak at the conferences. I'm a Google developer expert in web technologies, and I work as a Senior Frontend Engineer at Gitlab. And this all has nothing to do with D3. I just like it. That's why I'm speaking about it. So what is D3.js and what the name means? D3 stands for Data-Driven Documents. And it's actually a library that provides plenty of different methods to let you visualize your data in a nice and readable way. And when we speak about visualizations, first thing you think of is actually a chart, like bubble chart, histogram, anything like this. But you don't actually need pure D3 to do this. We have plenty of libraries to work with charts, like high charts. What I want to speak about is custom visualizations, like this. And if you think this is a contribution graph, it's not. In fact, it's just a humidity and change of humidity. And I'm really happy, because if it was a contribution graph, I would be worried about the guy or girl working on this part. Seems like no life. Actually, D3 can do some DOM manipulation to display data. And this is kind of similar to jQuery, because it can select different elements, it can insert and remove nodes, and it can change style, class, text, HTML, just to do changes to the image. But here is a problem. If you want to work with a framework already is doing some manipulations with DOM. So could we combine them both to make a nice visualization with a framework? In fact, yes, because D3 is separating DOM manipulation part to a separate package. We can take only things we need and use them. So let's build a Vueniverse. It's actually a set of stars representing Vue repositories. And each star has different radius, standing for amount of stars. And it's a bit outdated, because you see like 142,000 of stars for Vue core. And right now I think we have 152,000, right? More, okay. So, and yeah, I really hope someday it will be that big. What are we going to make? We will build a star, like a separate star, which is just an SVG. We will scale star properties depending on repositories characteristics. And we will add a dataset. And yeah, this is going to be a live coding session. So if you like people failing on stage, you're definitely at the right auditory. So let's look at a star and try to understand what exactly do we need to build it. In fact, it's just two different characteristics. It's a radius. In fact, two radiuses, but we can make inner one depending on outer, so it's one radius, and amount of stars, rays, sorry. and amount of rays. So, sorry, going to be a short math lesson. With amount of rays, we divide the whole circle on 5 equal parts, and it's like 2 pi divided by 5, because 2 pi is the length of the circle. Yay, like 7th grade. But we need more. We need points on the outer circle, but we need also points in the inner circle. That's why it's 2 pi divided by 10, which is rays amount multiplied by 2. Oops, no spoilers. So, let's start. We have this, we don't have this so far. I will just make it a bit smaller. We have just a background. This is an SVG. And we have some code. And please let me know if it's readable on the back seat. Okay, great. So we have an SVG, and we need to build an SVG path with D3 to display star. And as I said, we need 2 properties to define a star. This is radius, and it will call it outer radius. Let it be 250 pixels. And we also need an amount of rays. Let it be 10. Now, Vue has... Okay, who worked with Vue previously? Nice, I don't need to explain computed properties. Like less work. So we will define inner radius depending on outer radius, and I will make it just 2 times less. So let's have it like inner radius. Oh my god, this is like so unstable. Like Gitlab build. So this is going to be return this outer radius divided by 2. And now we will try to calculate these points I was showing on the outer and inner radiuses. So we need like 10 points for all the rays. Let's name them radial points. And first, let's define a step. Step will be just an angle we need to take for the next point. So it's easy. It will be math pi multiplied by 2 and divided this rays again multiplied by 2. We can simplify this, but I will leave it just for it's more understandable. We can just remove 2 from here. And we also have an array of points. Now let's iterate for all the rays. Sorry. This rays multiply by 2 for all points, e++. So we need also current radius, because for every single point we need to understand it's on outer circle or it's on inner circle. And it depends on the step. So for odd, it's going to be on the inner radius, otherwise for outer radius. I will just make it probably a bit... Okay, is it still readable? Thanks. And then we will do points push. It will be e multiplied by step and current radius. And we will return points from the computed. Thanks. I wonder why my VS Code didn't make a note, but okay. Let's go back to the browser and see what do we have as a radial points. In fact, we have an array of 20 points because I had 10 rays, and every single one is, first one is angle from 0, second one is a radius, so it's inner, outer, again inner, again outer, and there is not so much D3 magic, it's just a calculation. Now we need somehow to translate this to SVG path. because we just cannot draw this to SVG. And that's the moment where we will use first these three methods. And we will name it radial data. We will create a generator using line radial helper from D3. And line radial is a D3 function that allows you, I will just scroll it a bit, it allows you to create circle-based figures. And star is definitely a circle-based figure. As you can see, it's based from radius and angles. And we're going to return generator, and we pass our radial points here. Okay, let's see this. What did I do wrong? Hopefully nothing. Yeah. Like Sarah said, just refresh a page and everything gonna be fine. And you can see radial data is now a valid SVG path. If you never worked with SVG, it looks kind of like a magic, but you don't need to care about it. In fact, you just need to pass it to the SVG. So we have a D property equal to radial data, and if I didn't fail, we will have a star. Yay! Even without a refresh. Cool. Magic. So this is not the whole talk. So we just made a first attempt to draw a figure. And as you can see, star, you can think it's kind of weird. It's not a simple figure. It's not a circle, not a square. But with SVG, with these three SVG helpers, it's easy to build even custom figures. Now, let's go to the next step. And we are going to do some scaling on this star. Right now, it's just hard-coded. It has like static radius, static amount of rays. And we need to create scaling, because I have like SVG, which is 700 to 700 pixels. And what if I want to represent a radius? Should be a repository stars, but what if it has like 2,000 of stars? I just can't place it in this small SVG. That's why I need to use some scaling. I need to take a range that repository have for issues or stars or whatever else and change it to the certain range. And again, it's doing with a D3 helper. We will use the simpler scaling. It will be scale linear. So we will linearly change data we have to something we need. Like, imagine the amount of rays of the star. If I put 1,000, it will be just a circle, nothing fancy. So, sounds like a magic, but let's see how it works with the code. Imagine we have a repository that has like 200 issues, plus something like 100 contributors, and stars, let it be 2,000. Let's be optimistic about the repository. It's not Vue, so at least 2,000 is fine. Now we need to redefine our outer radius, because we're not going to hard-code it anymore. It should be dependent on stars amount. And yeah, I remember about comma. I saw like Dobromir was like, you're missing it. So here, we will define our scaling. Let's say it's like scale stars. And it will be scale linear, and scale linear is imported here from D3 shape. Again, it's great because it's fully tree-shakeable. You don't need the whole D3 library to work with. And here, first step, we define a domain. And let's think how many stars we will just scale right now. Let's say, let's go from 0, because there are some repositories without stars. I know this. I have some. And let's say the maximum for us is like 5,000. We don't need to care about repositories with more than 5,000 stars. And now we need to define a range. Range here is going to be a range to change the radius of our star. Let's start from 10 pixels. So if it's 0 stars, it's still going to be 10 pixel star. And let's end with, again, 2050. And let's return our scale stars function. No, not this one. And we need to pass these stars to it. Let's go, refresh, and you see the star is like a lot less because it's only 2,000 of stars and maximum is 5,000. So if we check the outer radius, it's going to be something like 100 pixels. Now let's do the same trick with arrays. Let's make arrays depending on amount of contributors. So again, the same boring function like scale contributors. Will be again scale linear. And again, the main is going to be something from 0 to, how many contributors do we have? 100? Okay, 300 at the maximum. And range. So now we change in arrays, and the star with 3 arrays looks kind of weird. So I will start with 4 and end with like 80. Now I need to redefine arrays here. So const race is scale contributors, where I will pass these contributors, obviously, but there is a trick. I'm not sure if it will show up. Oh, no, not now, because I need to change this race to race. But when I was first building this star, I was kind of confused. You can see that on the top, it's like maybe not that visible. I just make it a bigger. You see some small inconsistency with the race. If we change the amount of contributors, it's probably going to be more visible. Like, let's make it, I don't know, 50. See, again, it's like one ray is broken. And the question is like, why? Why it's breaking? Everything is correct. Except one thing. We need an integer here, and right now it's a float. So amount of rays is float, and when we pass this to the D3, it's like, I'm not sure how to draw this, so we need math around here to make it consistent. See, now it's like more or less correct star. And now there going to be something fancy, because we need to change also star color. And what I want to achieve, like if repository has lots of issues, we are going to make it red, because it's about star temperature. Red stars are the coldest stars. And if repository is kind of heated with many issues, we're going to make it blue, but I also want different star colors on the way. So it's going to be red, yellow, white, and blue. And again, scale linear can help you with this, because it's not only defining a range with a start and end. You can have as many points as you want. So first, let's make scale color helper, which again is scale linear. And the main gonna be, I want to have like 100% of my data, and I want to split it on 4 equal parts. So it's gonna be like 0, 25, 50, 75, and 100. 5 points, so 4 parts. And I need to assign colors to them. And I already have created star colors. And if you wonder what's this, it's just an array of colors. And this is white. This is like understandable. And now I also need to scale the amount of issues, because I need my issues to be scaled from 0 to 100, because I want to pass it here and then convert to colors. So we have also scale issues, which again is scale linear. I know it's kind of boring to have the same function, but I want to show how functional it is, in fact. So we will have a domain of, let's say, from 0 issues. How many issues do we have? 200. Oh my god, poor repository. So let's say 500, and we want to range it from 0 to 100. And we need to pass this color to SVG, because right now it's hard-coded, and I want it to change. Something is wrong, because I see it's gray, and I see console is like, no, it's a SOX connection. So let's check what do we have in our view, and why it's gray. Undefined. Did I forget to return it? Yes, I did. Because I still need to return scale issues, where I need to pass scale color, where I need to pass these issues. Okay. Still gray. Now I wonder why it's undefined. Let's make a check. And no, in fact, I need to... Oh yeah, correct. Thank you. Scale issues. Hey, magic. Now it looks like a yellow star, so kind of like a sun. It wasn't intended. But now it's still like a single star with hard-coded properties. What about dataset? And I still have like not enough probably time for live coding, so I'm going to do like live coding trick. Just discard everything you have and switch to the branch where you have the code. Because yeah, I can try to write it by hand, and I did, but it's really time consuming, and I want to explain what's going on here instead of our familiar code. So first of all, we added a dataset. And dataset here is just an array of view repositories with stars, issues, and contributors we've just seen. So the same properties we just created for our custom star. Now, instead of making the domain hard-coded, because we were defining like from 0 to what? 500, from 0 to 5,000. We want to take the minimal value for every single property in this array. So min value, if we pass issues here, we'll find the repository with a less amount of issues and take this value as the first value for our domain. Same for max value. So we are finding a maximum, and it will be the maximum for our domain. Next is like, let's take a look at computed first. So here is we're transforming repository data. And why we are doing this? Because we want to do this. We already did, so I will just skip it. And what do we do here? First, we want to build hierarchy. We take in the array of repositories. They will be the same on the same level, but we need to find out what is like the biggest star, what the lowest, and we need to pack them nicely. That's why we transform the data here. So we are putting them on the same level, and then we are building it with D3 helper hierarchy that takes all the repositories, checking their stars, because we're going to sort by radius, and sort them from the biggest one to the lowest one. And this is the magic method that helps us to build these nicely packed stars. It's just doing it for you, and if we check how does transformed repo data look here, I will just probably make it this way. So you can see there is, first of all, there is a radius, x and y here, and we have an array of children, and every single child here is a star. Every star has a defined radius and x and y positions, so it's transform. And also it has our good data object, which is like contributors, issues, and parent and stars. After this, we are building layout data. So we are just calculating star color, radial data, and we just given a name for gradient because gradient is different for every single star. And this is actually our familiar method. The only difference is instead of hard coding domain, we are passing minimum and maximum values. And we obviously also got rid of outer radius and inner radius because it's calculated by POC method. Every single star has a defined radius here. And in fact, that's it. I've also added some helpers just for tooltips, but this is obviously not obligatory. With all these methods, we can play with the stars. And yeah, this heated one is Vue CLI because it has the most issues. And this small one, like really small one, is one of my favorites. It's documentation. It has many contributors, but unfortunately not that many stars. So if you like Vue, go and start Vue docs as well, because we're trying hard. And this one is awesome. This has lots of stars because it's a collection of useful plugins and libraries. And yeah, this is Vue. And I think that's everything I wanted to say, so thank you.